Welcome. Let's solve Leetcode 2658, maximum number of fish in a grid. Okay, let's make this slightly bigger. All right. So the problem is asking us this. We're given this two-dimensional grid here, and they're asking us, let me just actually write this down. Which connected component has the largest amount of fish? Okay. So which connected component contains the largest sum of fish? So each one of these cells here, so this cell would represent that it holds 2 fish, and this cell here would represent that it holds 1 fish. Now, a connected component is any cell that can reach another cell. And the way a cell is connected is that if, well, it's either up, down, left, or right. So in this case, this number 2 cell only has 3 connecting cells, 0, 1, and 0. However, 0 indicates a land cell, and the numeric cells greater than 0 represent a cell containing fish, and hence this 2-1 block or collection of cells cannot reach any other cells, because this is a land cell. The surrounding cells are land cells. So in this particular first example, there are 3 components, separate components. So this component of 2 and 1 has a total of 3 fish. The collection of cells 3 and 4 have a total of 7 fish, and notice that's actually the answer here. These bottom 2 cells, 3 and 2, they cannot connect to any 2 cells because they're surrounded by land cells indicated by the 0, contain 5 fish, and same thing over here for 4 and 1. These 2 cells are a separate component, and they contain a total of 5 fish. So in any case, they want us, so we can go back to this here. They say return the maximum number of fish the fisher can catch if he chooses his starting cell optimally. So in this case, if the fisherman chose to start at this bottom 3 cell, he could only reach this other cell to the right, which would give him a total of 5 fish. It would be better for him if he started at one of these 3 or 4 cells, and in that case he could get, or can optimally retrieve 7 fish. And they're saying it's possible that there are no water cells. So in that case, the answer would be 0. Okay, I could just go over this real quick. So a fisher can start at any water cell, and a water cell is where any value is greater than 0. A land cell is where the cells equal 0. So a fisher can start at any water cell and do the following operations any number of times: catch all the fish at cell RC, or move to any adjacent water cell. Okay, so I think I'll just kind of leave this up and just jump to the coding. So for almost any problem where there's a grid, we'll want to retrieve the dimensions. So we can do that now. Let's retrieve the dimensions. So let's get the dimensions of this grid. So let's call this G. So let's get the dimensions, and we'll store the results. The result will be 0. We'll get the number of rows and the number of columns. So the result will be 0. The number of rows will be the length of G, and the number of columns will be the length of the first row. Okay, so now we have that. We know eventually we want to return the result, so let's just do that now. And if I haven't gone over this yet, what we'll do is we'll loop through our grid here, and everywhere we see a non-zero cell, we'll explore that. So in this case, if we see this first cell, we'll skip it because it's a 0. In this case, we see this 2, so then we'll say, okay, we're going to explore the cell. So we're going to go to this cell, and we're going to add up all the cells that are non-zero. And so we'll go here. After we explore this 2 cell, in order to prevent us from revisiting this cell, we'll mark this as 0, and then we'll move on to this 1. And that will help us reduce the memory size of our solution. So let's kind of go over that now. So we'll use directions here. Directions dirs equals. This will help us because for every cell we'll want to explore up, right, left, or up, down, left, or right. So 0, -1, 1, 0, -1, -1, 0. Okay, so now let's write the outer method to loop through all of these cells. So let's say for R in range row, for C in range column. Now remember, if we visit a 0 cell, we want to skip it. So we can say if G of RC is not equal to 0, we can explore it. We'll just call this, we'll call it explore. We'll explore that cell and neighboring cells that we can connect to. So we'll explore that cell, so we'll say R, C. And what this will do, it'll return a value. So we'll just call this maybe num of fish, and then we can compare the number of fish with our current result. So we can say result maybe if num of fish is greater than result, result equals num of fish. Okay, and then we can return result. Okay, so what we're doing here is we're looping through all of the rows and columns, and if one of the cells is a fish cell, we'll explore it. And in this explore method, we're going to count the number of fish using maybe depth for search. It really doesn't matter which type of a search we use. Okay, and then as we loop through every cell, we'll mark each cell as 0 to indicate visited. Okay, so let's do that. So we'll say define explore, and we'll call this row, column. And so we'll initialize our total. So for example, suppose we're here at 2, this first cell. So we can initialize our total, and we'll say that's going to be G of that row and that column, and we'll return that. So now from this cell, we want to explore all the neighboring or adjacent cells. So here, the adjacent cells, we can go up, down, left, or right, as long as they're within the grid. So let's do that. So we'll say, well, let's do something first. Let's mark this cell as visited. So it's visited. So now this cell will be value 0. It doesn't matter though, because we've already retrieve that value. Now we're just set to 0. So now let's explore the neighbors. So we'll say for dr dc inders, which is this here. And then so we'll say the new row and new column equals the old row plus the delta row, the old column plus the delta column. Now we want to check if this new row and column are within the grid and it hasn't been visited before. So so g of RC. So if this is 0, this will be false. Any other value it'll be true. So I'm just going to leave it just like this. Because if this is 1 or 2 or 3, it's truthy. So it's truthy. So it will be allowed to enter the if block. Okay, so if all of these are true, so if the row is within the bounds of the grid, if the column is within the bounds of the grid, and this cell value is other than 0, then we can explore it. So we can say we'll explore that new row and that new column. And remember, this is going to return this returns the number of fish, the total number of fish, returns total number of fish within a component. When I say component, it means like reachable. So for example, if we're at this cell 2 here, we can reach cell 1 because it's adjacent and it's not a land cell. Same thing for this 4 cell. For this 4 cell, this 1 cell to the bottom is reachable, and it's also in the same component. Okay, so let's continue on. So this will return the total number of fish retains the total number of fish within a component that are reachable. Okay, so let's add that to our total. And then at the end of this function, we'll return total. Okay, so that returns that. Oh, my apologies, I think I already did that. Okay, I think that's about it. Let's test it out. Okay, the test run fine. Let's submit it. I may try a subtle rewrite. So okay, looks very good. It looks fine. Something that's maybe a little bit cleaner is that we can probably do something like this here. So instead of these 3 lines, I can probably rewrite it like such. So the result equals the max of result and explore RC. So I'm going to take off these 3 lines, and so this is how it looks now. So it just looks a little bit cleaner, and I doubt it'll alter our performance. So in fact, it made it slower, but it looks a little bit cleaner. I'll just submit it again just to see how it goes. Okay, but if we use the longer version, sorry. This is the longer version. So it seems to, the tests seem to appreciate this one better because the max function, this is the function, and it uses more resources than the simple if clause. So that's why I would guess. Well, actually, I'm more certain. Sorry, I don't need to guess. I'm certain of it, is that this if clause. So imagine always doing work versus only doing work sometimes. So that's what this is. This if block says we only do work sometimes. But if we always, this always does it. So that's why it takes a little bit more time. Okay, and that's about it. If you found this video helpful or beneficial, please consider liking or subscribing, or both. Other than that, have a wonderful day. Take care of yourself. Cheers.